So yesterday and the day before we did multiplying probabilities, and today we're doing adding probabilities. Well, adding probabilities is used when there's an or involved in the problem. So you have, let's say you have 7 women and 6 men walk into a computer store, and you want to know the probability that the salesperson will help 4 women and 1 man, or 4 men and 1 woman. Okay? Well, when you have a probability with an or on it, we've got to add the probabilities of both things happening. And here we have a group of 13 people. So we're going to look at each situation separately. The first situation, we're going to say, okay, we have 4 women. Well, there's 7 women, and we're picking 4 of them. And remember, we did the combinations, the NCR on the calculator? Well, we're going to pick 4 women out of the 7, and we're going to pick 1 man out of the 6. And then on the bottom, you always put the total you're picking from and the total number you're picking. Okay? So you would put combination 13, 5 would be at the bottom. So you're going to do all those combinations in your calculator. And then you're going to do the other scenario, which is out of the men, 6 men, you're going to have 4 that you're picking. And then out of the 7 women, you're going to have 1 that you're picking. And that's over combination 13, 5, because you're picking a total of 5 out of the 13 people that came into the store. So you've got the probability of the first scenario and the probability of the second scenario, and you're going to add them together because it's an or. When you have an or, you add the individual probabilities together. So when you do NCR 7 NCR 4 on the calculator, you get 35. When you do 6 NCR 1, you get a 6. And when you do 13 NCR 5, you get a 1287. And here you get a 7, 6 NCR 4. You can check it on your calculator. No, I'm sorry. You get a 15 here, and you get a 7 here, and you get a 1287. So then we're going to multiply 35 times 6. And that's 210 over 1287 plus 15 times 7, which is 105 over 1287. And you put that in your calculator, and you get 315 over 1287. And 315 divided by 1287 reduces to 35 over 143. So that means you have about a 24% chance of that happening, of one of those 2 scenarios happening, because the decimal was 0.244 before you turned it into a fraction. That's about a 24% chance, but you can leave this as your answer. If it doesn't turn into a fraction, you can leave it as a decimal, round to 4 places. So if we have the same scenario, we have 7 women and 6 men, but they want us to do all women or all men. Then we're looking at 7, 5 over 13, 5 plus 6, 5 over 13, 5. Now, when you do all women, you're picking 5. You could technically say, okay, I'm picking 5 women that I would have 0 men. but 6 comma 0 is 1, so it's not going to change the answer, but you could put that on there too if you want to. So if I'm picking 5 women, all women, I would have 7 comma 5, 6 comma 0, which is 1 times 1. And then if I'm picking 5 men, it would be 6 comma 5, and that would be 7 comma 0. And you can put that on there, but you don't have to. So the 13 comma 5 is still 1287. So, once you get that number for the bottom, that's always going to be for all the problems in the section. 7 comma 5 is 21. And 6 comma 5 is 6. There's 6 ways to pick 5 people out of a group of 6. So you're going to have there is 27 over 1287, and 27 divided by 1287, when you reduce it, is 3 over 143. So it's a little bit harder to get all women or all men because there's almost an equal amount of each one, so it's going to be harder to have that happen. Now this next one is a hard one because it says probability of at least 3 women. Okay, so at least that's the least amount of women that you can pick, and you're picking still 5. You're still picking 5 people when you're helping these people, okay? So there's 5 salespeople, so you're picking 5 people. So at least 3 women means if you're picking 5 that either you're going to pick 3 women, 4 women, or 5 women. So you have to do each of those scenarios and add them together. So when I pick 3 women, I have 7 comma 3, and that means I would have to have 2 men, 6 comma 2, right? And then when I pick 4 women, I would have to put 7 comma 4, and that would mean I'd have to have 1 man, 6 comma 1. And when I pick 5 women, it's 7 comma 5, 6 comma 0, because that would mean I would have no men. And all of these are over that 13 comma 5, 13 comma 5, 13 comma 5. Okay, so let's do the math on that. So 7 comma 3 is 35. And 7 comma 4 is 35. And 7 comma 5 is 21. We did that earlier. 6 comma 2, let's find that, is 15. And you can look at other problems. If you've already found these, you can look and use them again. 6 comma 1 is 6. And 6 comma 0 is 1. Okay, and then 13 comma 5 is 1287, which we've done all along. And so now we do 35 times 15, which is 525 over 1287, plus 35 times 6, 210 over 1287, plus 21 over 1287, and we add those together. 525 plus 210 plus 21 is 756 over 1287, which reduces to 84 over 143. So that's the probability of there being at least 3 women, which means 3, 4, or 5 women, because you're picking a total of 5.